Alright students, here's your video for you. We did this on Tuesday, I think it was. So here's a little bit of extra practice. We're going to rush through this, so keep with me. When you're multiplying radicals, if the numbers are inside the radical, you can multiply them together. 30 times 10 is 300. After you multiply them together, you must rationalize the number inside. In other words, I want to know what perfect square goes into 300. Well, that's 100 times 3. 100 is my perfect square. Square root of 100 is 10. So I get 10 root 3. Root 30 times root 10 is 10 root 3. The perfect square is 2 times 2 is 4. 3 times 3 is 9. 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, and so on, all the way. 9 times 9, 10 times 10, and you can keep going. You shouldn't have to go bigger than this most of the time, but we are looking, when we simplify a radical. When we simplify a radical, we're looking to see which one of those numbers is going in, starting as big as possible. Now, when you're multiplying radicals and you have a number on the outside, that will never multiply to the inside. It'll only multiply to the outside. So we're going to multiply 10 times 12. We end up with negative 6 on the outside, square root 120. And then when we go through our perfect square numbers, we find out the biggest number that goes into 120, that is one of these numbers, okay, is the square root of 4. Square root of 4 times the square root of 30 is the square root of 120. The negative 6 still is outside. We can take the square root of 4 and get 2. Now the 2 is on the outside, and it can multiply to the 6, and we will get negative 12. 2 times 6, square root 30. So the numbers on the inside multiply, and then we simplify, trying to find one of these numbers in that bigger number. Once we simplify it, we can multiply. Now here's a big rule that comes up quite often. If you ever have a square root times itself, it's just going to be the number. Doesn't matter how big it is, any square root times itself is just the number. Now, radicals are never allowed to be in the denominator. Okay? That's no good. So how do we fix that? Well, to fix that, you're supposed to multiply by the denominator over itself. Not the numerator. Numerator doesn't matter, only the denominator. We multiply straight across, we get 2 square root 2 up there. Multiply straight across, you get this, well, wait a minute, same number. So it just should be 2. If you multiply the inside, you see that's the square root of 4. But the square root of 4 is just 2. So we could have gone straight to this. Then always look to see if these numbers can reduce, and they do, they cancel out. So we just get square root of 2 as the answer. Try it again here. Multiply by radical 3 over radical 3. Multiplying straight across, 3 times the square root of 3. Square root of 3 times itself is just 3, and oh, the 3's cancel. So we get square root of 3. What if we have something deeper? Okay, multiply by the square root of 2. Now these are both in the radical, so they become square root of 10, 5 times 2. And then same number, so it's a 2. Now, the 2 cannot cancel with the 10, because the 10 is inside, the 2 is outside. Here, they're both radicals. Hey, because they're both radicals, you can actually consider them as one radical, and 2 goes into 10 5 times, so we get square root of 5. Okay, so we could actually go here, since they're both inside the radical, we can go, oh, 2 goes into 10 5 times. Get our answer. Here, this is a perfect square. We have to recognize it. It's right here in our numbers. We have to recognize that. What is the square root of 16? Anytime I get a perfect square number, I want to, like, simplify it. Oh, wait, the 4's cancel. And then we get square root 15. So I don't have to, in both those problems, I didn't have to multiply by the denominator over itself, because this one it simplified out ahead of time, and this one had a perfect square. Now the back side. We'll get this done here. Okay, here, I'm wondering about this 48. I could try to simplify it, okay, but what I should try to do is see, does 3 go into 48? So I'll just come here with the calculator. 16. Oh, good. So that means this cancels and this cancels. 3 goes into here 1 time, and 3 goes into here 16 times. So it reduces. I'm allowed to do that. I can't cancel with this. It's on the outside. What is the square root of 1? Square root of 1 is just 1. I got a 3. What is the square root of 16? It's 4. So I get a 1 over 3 times 4, which is a 1 over 12. Okay, let me write that out a little bit. Once I cancel reduce the 3 and 48, I get square root of 1 over 3 square root of 16. Square root of 1 is 1, and the square root of 16 is 4. All right, from here, see if I still have my picture. I drew a picture. Here we go. From here, 30, 60, 90, and 45, 45, 90. We're going to use these two things. Take a pause and copy them down, memorize them, okay, in a 45, 45, 90, okay, and I know it's a 45, 45 if I know at least one of the angles with the right angle. But the two sides here, the legs that form the right angle, are both the same. So I say n. Then the hypotenuse will be n times the square root of 2. If they have an n in the problem, I'll change the letter. I had x, someone else said, no, do p. I could have done b. Okay? I could do whatever letter I want. So I look here, I already have an n in the problem. So what I'm going to do, the two sides that make the right angle are both going to be x instead of n. Then that means the hypotenuse will be x times the square root of 2. Now when I look at these things, see, every single time I want to create 3 little equations. But when I look at them, this one is the only one that has a single variable. This has an n and an x, an m and an x. I want this one. Once I figure out what that new variable is that I put in, I take and plug it in. Plug it in both spots. If I plug it in down here, n in my problem equals x, but x is 5. So that means n is 5. Put the 5 here, m equals 5 times square root of 2. We're done. That's like too easy. What about this one? Now I'll go back to using n's instead of x's. The two sides that form the right angle are both n. The hypotenuse opposite the right angle is n square root 2. Well, again, right here, I know what n is. It's an ugly number, but I know what it is. If I plug it in here, I know what b is. b is the same exact thing. If I take this and plug it in here, a will be this number times the square root of 2. n times the square root of 2. Now we got to work this out. Now if I have a fraction times something, I like to make the other thing look like a fraction. Helps me visualize. But if I'm multiplying, okay, the denominator of this is the easy part. 2 times 1 is 2, so that's 2. The numerator, let's cover that up. The 3 is outside, and they have the square root of 2 times itself. So anytime a square root times itself, that's just the number. So I have the 3 on the outside, and then square root 2 times square root 2 is 2. So now I really have 6 over 2, but I can see the 2's cancels, so A is 3. So B was easy. A, I had to do some work. Multiply things out. Now, the 30, 60, 90. I know it's not 45, 45 because it doesn't say 45. It says 60, so I know it's 30, 60. So I use this template. Opposite 30 is n. Opposite 90 is 2n. Those are easy. Then opposite 60 will be n square root 3. Now the other one was square root 2. Okay, the way I memorize it, it's square root 2 because I have 2 of the same angle. It's square root 3 because I have a 30. Okay? So we're going to come in here, and I'm going to say this. Now where's the 30? I don't see the 30. Well, if that's 90 and that's 60, then this one has to be the 30. Okay, never assume, always make sure. So opposite 30 is n. Opposite 90 is 2n. That means the last one is n square root 3. And again, this is the only one with a single variable. This has n and b, this has a and n. 2 variables each. I need the one with a single variable. So 2n equals 18. Okay, from here, we're going to divide by 2. So n is 9. I'm going to take that and plug it in there. And we're going to take that and plug it in there. This is easy. N is 9, so B is 9. This is easy. N is 9, so A is 9 square root 3. Don't cry at me, this is easy. All right, I have n's again, so I'm going to change them up. This is 30. So as I go opposite 30, I get x. Opposite 90, I get 2x. Opposite 60, I get x square root 3. I change it to x because there's already an n. My only problem is here. 1 variable there, 2 in those. So I need to solve that. So I'm going to say x square root 3 equals 4. This gets messy. This is the messiest one. Divide by square root 3 on both sides. That cancels. I get x equals 4 over the square root of 3. You're not allowed to have that. So we have to multiply by square root 3 over square root 3. Because remember, no square root in the denominator. This will give me 4 square root 3, and these are times itself, so over 3. Does the 3 go into the 4? No. Okay, so now I'm switching colors. No, I'm not. This here is x. Plug it in here. N equals 4 square root 3 over 3. Plug it in up here. M equals 2 times 4 square root 3 over 3. If I make this a fraction, 2 over 1, then I can multiply straight across. 2 times 4 is 8. 1 times 3 is 3. And so I get n, and I get m. There you have it. It is not as hard as we want to think. It may be weird, but not as hard.